All right, let's dive right into this explainer. Today, we are building a definitive defense manual against the statistical dark arts. We live in a world that is literally overflowing with data. And let's be honest, the secret language of statistics is constantly being used to sensationalize, inflate, confuse, and oversimplify. From advertisers trying to sell you a new toothpaste to massive corporations trying to prove a very specific point, numbers are frequently weaponized to deceive us. But don't worry, by the end of this explainer, you're going to be a highly savvy consumer of information. We're going to learn the tricks of the trade, not so we can use them ourselves, but because honest people absolutely must learn them in self-defense. So let's kick things off with a seemingly simple question from a 1924 survey reported by Time magazine. Do Yale grads really make $25,111 a year? Now, this figure is obviously meant to impress you. It's supposed to be cold, hard evidence that if you go to a prestigious school, you are just set for life. But take a closer look at that number. Two things should immediately jump out at you. First, 25,111, it is surprisingly, almost suspiciously precise. And second, for an average income in that era, it is improbably high. No way that's typical. So how did they actually arrive at this impressive 25,111 figure? Well, let's lift the hood on this one. This figure is based off a sample, meaning they mailed a questionnaire out to the alumni. But who actually answered it? They can only mail it to graduates whose current addresses were known. The little lost sheep, the clerks, the tramps, the folks that were unemployed, they were never even reached. And of those who did receive it, who actually took the time to reply? Probably the ones making enough money to brag about it. The folks struggling to make ends meet likely chucked that questionnaires straight into the wastebasket. So the absolute crucial point here is that this number doesn't represent the average Yale grad at all. It represents the highly successful ones whose addresses were known and who really wanted to boast. So here is our survival roadmap for today. We're looking at the 6 most common statistical tricks: biased samples, the well-chosen average, missing figures, deceptive visuals, semi-attached figures, and finally, correlation versus causation. Let's get into it. Section 1. Beware the biased sample, the flaw in the foundation. You see, the method used to gather data can totally rig the results before the math even starts. The 1936 Literary Digest poll is a brilliant illustration of this danger. The magazine ran this massive poll predicting the presidential election. 10 million people were polled, and the result? Landon 370, Roosevelt 161. They predicted an absolute landslide for Landon, but as history shows, Roosevelt won. So how could a massive poll of 10 million people be so spectacularly wrong? Well, because the magazine sourced its sample directly from its own subscriber base and from telephone directories. In 1936, right in the middle of the Great Depression, people who could actually afford magazine subscriptions and telephones were economically a very specific group. The sample was unintentionally but heavily biased toward wealthier voters. To actually avoid this, you need what's called a true random sample, which means every single entity in the whole group has an exact, equal chance to be chosen. Think of it like pulling names from a giant hat. But purely random samples are incredibly expensive and difficult to pull off. So pollsters often use a cheaper substitute called stratified random sampling, where they tell interviewers to go talk to a specific percentage of certain demographics. But this often fails too. Human interviewers introduce hidden biases. They might be told to interview people over 40, but they avoid a dirty, surly-looking guy on the street in favor of a neat, friendly-looking one. Boom, the bias creeps right back in, completely ruining the data. Moving to trick number 2, the well-chosen average: mean, median, and mode. Mathematical manipulation can create entirely different realities from the exact same set of honest data. Picture a business owner who really wants to brag about how well he pays his staff, so he proudly claims the average wage is $5,700 a year. That right there is the boss's average, the mean. He got that by adding up everyone's pay, including his own massive $45,000 profit, and dividing by the number of people. But the workers on the floor might say, wait a minute, we don't make anywhere near that. The workers' average is a median, the number sitting right in the middle, where half the people make more and half make less. That median might be just $2,000. Both averages are mathematically perfectly correct, but only one gives you the true picture of the working man's reality. Let me give you another scenario. Imagine a real estate agent trying to sell you a house in a neighborhood, boasting that the average income is a whopping $15,000. Great, right? But then a year later, you're fighting a local tax increase, and a taxpayer committee claims the neighborhood is actually quite poor with an average income of only $3,500. So who is lying? Actually, scratch that. Neither of them are. The 15,000 is the mean, skewed heavily by just 3 millionaire weekenders who happen to have massive estates nearby. The 3,500 is the median, the true midpoint of the regular everyday residence. And the mode, which is the single most frequent income, is $5,000. When someone just tosses out the word average without specifying which one they're using, they are deliberately keeping you in the dark. Trick number 3, missing figures and ranges, what they aren't telling you. Often, the absolute most deceptive thing about a statistic is simply what they leave out. Here is a classic advertising trick. You see a big, bold, flashy headline, "Users report 23% fewer cavities with Dox's toothpaste." It comes with a fancy independent lab report, it's certified, the whole shebang. It sounds fantastic. But what's the missing figure here? Read the tiny print at the bottom. The sample size. The test group consisted of exactly 12 people. Listen, if you test any product on just 12 people, pure random chance dictates that somebody will have fewer cavities. And if they don't, well, the company just throws that test away and tries another 12 people over and over until they get the exact result they want for their headline. Here's another missing figure trick. Look at this specific number, 60.2. This is the average annual temperature in Oklahoma City over a 60-year period. It sounds perfectly pleasant, right? A mild, super comfortable 60 degrees all year round. You might think it's a great place to move to based on that one incredibly precise number. But what they aren't telling you is the range. The record high there is a roasting 113 degrees, and the record low is a freezing -17 degrees. That is a massive 130-degree swing. Precision does not equal accuracy. A comfortable 60.2-degree average means literally nothing if you completely ignore the extremes. Always, always ask to see the range. All right, trick number 4. Deceptive visuals and graphs. Enter the gee-whiz graph. Visuals can manipulate our eyes incredibly easily. Imagine a graph showing a modest 10% rise in national income over a single year. Drawn honestly with the bottom of the graph starting at 0, it looks like a gentle, steady, kind of boring upward slope. But if you want to win an argument or shock a reader, boring lacks drama. So what do? You just chop off the bottom. You start the graph right at the 20 mark instead of 0. Suddenly, that exact same 10% rise looks like a massive, towering cliff that is shooting straight up into the sky. The underlying numbers haven't changed at all, but the visual impression is completely falsified. And honestly, it gets even worse when we look at pictographs. Let's say you want to compare a $30 wage to a $60 wage. An honest bar chart just makes the $60 bar twice as tall. Done. But advertisers love eye appeal, so instead they use a picture of a money bag. To show the $60 wage, they draw a second money bag that is twice as tall as the first. The catch? By making it twice as tall, they naturally also make it twice as wide. So visually, it takes up 4 times the area. And because it's a 3D object, your brain subconsciously processes its volume. 2 times 2 times 2 means the visual volume is 8 times larger. You're technically saying double with the numbers, but your visual is screaming 8 times as much. Which brings us to trick number 5, the semi-attached figure, essentially answering the wrong question. Here's the golden rule for swindlers. If you can't prove what you actually want to prove, just demonstrate something else entirely and pretend it's the exact same thing. Take this advertiser's boast for a brand new juice extractor. Extracts 26% more juice. It's proved by a laboratory test and vouched for by an official institute. Hey, if it's 26% more effective, you should definitely buy it, right? But wait, ask yourself the Socratic question here. 26% more than what? When they are actually pinned down, the truth comes out. It just extracts 26% more juice than an old-fashioned manual hand reamer. It has absolutely nothing to do with comparing it to other modern motorized juicers on the market. The statistic is totally 100% irrelevant to your actual purchasing decision. They proved one thing and pretended it meant another. Here is another semi-attached figure for you. An article once warned that 4 times more fatalities occur on the highways at 7 p.m. than at 7 a.m., strongly implying that the evening air is inherently 4 times more dangerous for you to be driving in. Is it? No way. This statistic simply reflects the fact that there are vastly more people driving on the road at 7 p.m., commuting home from work, to get into accidents in the first place. The total number of deaths does not tell you your individual risk rate. And finally, trick number 6. Correlation is not causation. Post hoc rides again. Just because event B follows event A, we automatically jump to the assumption that event A caused it. For example, a study once showed a very real correlation between college students who smoke cigarettes and lower overall grades. The immediate, loudly proclaimed theory was, smoking causes low grades, it dulls the mind. But hold on a second. Couldn't it just as easily be that bad grades stress students out and drive them to smoke? Or, actually, even more likely, is there a hidden third factor? Sociable extroverts might be more likely to smoke, and those same sociable extroverts might also naturally spend less time studying in the library and more time partying. The correlation is totally real, but the cause and effect conclusion is completely unwarranted. Let me share a fascinating little anecdote that perfectly captures this. For centuries, the people of the New Hebrides Islands firmly believed that body lice produced good health. Why? Because basic observation taught them that healthy people usually had lice and sick people often did not. The correlation was practically 100% real, but they completely missed the actual cause and effect. It turns out practically everyone there had lice normally, but when a person got sick and ran a fever, their body became too physically hot for the lice, so the lice left. The fever drove the lice away. They confused the effect for the cause entirely. So, we have covered biased samples, skewed averages, missing figures, deceptive visuals, semi-attached logic, and false correlations. Which leaves me with one final question for you. Will you let the next statistic you see swindle you, or will you ask to see the missing figures? The next time a number tries to shock you or sell you something, take a step back, remember the swindler's toolkit, and look for the real truth hiding behind the data. Keep questioning, keep learning, and I'll see you in the next explainer.